So atomic structure and the periodic table. The first question is atom X has 8 more electrons than atom Y. Student 1 says they are in the same group, and student 2 says they are unreactive. Okay, so let's say if atom X has more electrons and atom Y is completely filled in, so this is why they move to the next shell. So to the next shell we have 8 electrons, that would be group 8 or group 0, so it will be unreactive, so student 2 is correct, and student 1 says they are in the same group. So usually when you add 8 more electrons you move on to the same group number, which give you also 8 electrons in the last shell. So both are correct. Now if you're confused about this, you can just pause the video and try to look at this explanation here. And then you realize that they will be in that group here. Question 2. For isotopes, so for this one you should be able to know the definition of isotopes. Isotopes are the same type of atom. So if we're talking about calcium, we still talk about calcium. So the proton number has to be the same, because when you talk about element, the proton number is the same. If you change the proton number, you have a different element. So it has to be same proton number, but then the neutrons are different, or the nucleons, because nucleon consists of protons and neutrons. If the proton is the same, the neutron is different, hence when you work out both of them, the nucleon is also different. So the number of electrons should be same, because if the number of protons is same, the number of electrons is also same, as you know it. And we are talking about element, it's not ions, so electron will be same. If we talk about electron, we talk about shells, so shells will be same, proton will be same, but not nucleon. The two things which will be different is neutrons and nucleon. That's the only thing which will be different. 3. Which atom has 2 more electrons than an atom of a noble gas? A noble gas will end up with 8 electrons, and if we have the extra electrons, so that would be the different groups. So if we look at aluminium, it is in group 3, so 3 electrons, not 2. Bromine is 7. Rubidium is in group 1, so 1, and calcium is in group 2, so it will have 2 electrons as compared to the noble gases. Element S has the proton number 18. The next element in the periodic table is an element T. Which statement is correct? So if we look at our periodic table, I think this is the easiest thing to do, is to have a periodic table. It has the proton number 18, so that will be argon, right? So the next element of the argon will be potassium, where there's only 1 electron extra as compared to S. So this is argon, so potassium would be here with 1 extra electron. Number 5. So what is a nuclear number? A nuclear number, whether it is for an atom or an ion, it is the same thing. Because the difference between an atom and an ion is only the number of electrons that changes. So if you're talking about nuclear number, the protons and the neutrons, that will be same, except if they are isotopes. So proton number and neutrons, adding them together is your nuclear number. Is how many particles you have in the nucleus. 6. Element V forms an acidic covalent oxide, which roll the table shows how many electrons could be there in the outer shell. So to form an acidic oxide, we haven't learned it yet, but yes, it helps when it says covalent. So covalent has to be between non-metals and non-metals. If it is non-metals, you can't have 1 electrons in the outer shell, because that would be in group 1, and group 1 are metals. If you have 2 electrons in the outer shell, that's group 2, and as you know here in the periodic table, all group 2 are also metals. But then if you talk about 6 electron in the outer shell, that's group 6, and all elements in the group 6 are non-metals. And all elements in group 7 are also non-metals, so they form covalent compound. That's why 6 and 7 would be the right answer. 7. So element X has a nuclear mass number of 19 and proton number of 9. So the trick is to be able to identify an element, always look at the proton number, because this is the only one which won't change at all. If you change the proton number, it gives you another element. So if I want to know what element that it's talking about, I look at 9, the smallest number 9 in the periodic table, and that will be fluorine. So it's actually talking about fluorine right now. Hence, where's fluorine? So if you have your periodic table, you see that fluorine is in group 7. So that will be easy to figure out. Always look at the proton number, because when you look at the nuclear number 19, it might be sometimes bigger number or smaller number as compared to the periodic table, because now we can also talk about isotopes. So make sure look at proton number, the small number. For that one, we need to find W, X, Y, and Z. So W is here, number of neutrons. To find the number of neutrons, you take the nuclear number, the big number, minus the protons. So 24 minus 12 is 12. So it will be between C and D. Then we look for X. So it's the proton number, which does not change for atom or ion. If this is 12, this is also 12. That's why it gives us this one. Now, of course, you can try Y and Z if you're not sure about if D is the answer. But to be on the fast pace in exam for multiple choice, once you know exactly, you can figure out from W and X. You don't need to figure out Y and Z, you already know. But if you're not confident, then you keep looking and figure out the best answer. 9, which two isotopes? Alright, so remember isotopes is same number of protons, same number of electrons, but the neutrons are different. So the N will be different. Okay, so let's look at this. Now remember, so we have one proton and one proton. So you have only one here, there's 2 here, so that's wrong. 1 here, that's okay. So we can eliminate C from this question, from this answer. Then we have, for that one, the number of neutron will be 0, because 1 minus 1 is 0. So there's no neutrons for this, because there's no neutron. Here we see neutron, so that's wrong. Here we see neutron, that's wrong. We get the answer is here, because there's no neutron here. Then you can double check your answer again. You compare 1 proton, 1 proton. 2 minus 1 is 1, so 1 neutron, 1 neutron. And of course, if I have 1 proton, that would be 1 electron as well, which is here. It's a bit like this, how it looks like. So this is H11, this is H2 and then 1, and tritium is H3 then 1. So they're called isotopes of hydrogen, but they have different names for these ones. So the isotope, this one here, is called hydrogen. This is called deuterium. And then we have H31. This is called tritium, which is here. It's good to know that. And as you can see, the protons and the electrons is same. It's only the neutron which changes. 10. Which row shows a change that takes place when element X gain the new particle shown? Okay, let's see. If particle gains electron, it becomes an ion. It can be positive. So gaining electron would be, if I'm taking electron, I would be someone who's negative. So it would be a negative ion. Here it says isotope, so that's wrong. Element. The element one placed to the right. So it's trying to say that it's changing position from the periodic table. So that's that's proton number, because when you change a proton number, you move on to another element. But here, we're changing electron and saying this, so that's wrong. Proton, no, proton is the same, because when you talk about isotope, it's only neutron that change. And here it says if you change the proton, then yes, if I increase the proton, let's say for example, I take the periodic table and I say, okay, magnesium is 12, I increase the proton to 13, now 13 is no more magnesium, it's aluminum. So when you change the proton number, here for example it says by 1, you move to the right of the periodic table. For example, magnesium, you move to the right, you get aluminum, you add 1 more proton, you move to the right, again you get silicon. So yeah. 11. So how many proton number and neutrons? So proton, if I have 4 electrons, I would have 4 protons. So between A and B, because it's an atom. If it was an ion, it would be hard to figure out how many protons, because the number of protons and electrons will not be the same. But if it is an atom, proton and electron are the same. So if I have 4 electrons, I would have 4 protons as well. And hence the neutron, if I know what is my atom, so it's 4, so that's beryllium, the smallest number from the periodic table, 4. That's beryllium, and beryllium has 9 nuclear numbers, so 9 minus 4 is 5, so neutron is 5. And if you have beryllium here somewhere? No, I haven't written. It's easier to have your periodic table for these questions. Now it says which statement is correct. Okay, so as soon as I see this, I can see the proton number is not the same here. So I know it's different element, it can't be the same element. I can also see it's 52 and 52, so I know that it's equally heavy. So let's see. They are different elements because they have different number of neutrons. They are different elements, but not because of the neutron, because of the proton, which is different. They are different elements because they have different number of neutrons. So that's the answer. They are isotopes. They are not isotopes because to be isotope, they have to be the same element, means same proton number. So they are not even isotopes. So this does not even apply C and D. You have 2 isotopes of helium, which 2 diagram shows the arrangement of this. Okay, let's look at this one. So helium will have 2 protons, and this helium will be 2 protons as well. Let's check. 2 protons, fine. 1 proton, so that's wrong. 2 proton, that's right. Wrong. So it's between A and C now. Then we look at let's say for example number of neutrons. So 3 minus 2 is 1 neutron. Good, 1 neutron. Here will be 4 minus 2, 2 neutrons as well. So 2 neutrons, and 2 is fine. Number of electrons will be same as protons. So if I have 2 protons, I will have 2 electrons. 1, 2, but this is 3. So this is wrong. And here, if I have 2 protons, it will be 2 electrons. Again, we have 4, so that's wrong. So 2 electrons, so that one. 14. Correct value of X, Y, and Z. Okay, let's try X. Electrons, okay. So we have 8 protons, so electrons should have been 8. But then is O2 minus. Oxygen is being negative by taking 2. So taking 2 extra, so 8 plus 2 is 10. So then X will be 10, so between C and D. Now we don't need to look at Y because it's always both are 12 and 12. Otherwise we lose time. Remember, multiple choice is 1 minute on average. And then we have Z. Z is to find the number of electrons, okay? So we have 11 protons, and sodium has been positive. Remember, positive people give. So giving away 1. So they had 11 at the beginning, and they're giving away 1, so that made it 10. So that's why it's here. Which element is correctly matched with its electronic structure? So 2, 8. Oh, okay. So 2, 8, 1 for this one. It does end with 1. If you look at the period means the number of shell. So this is period 1 and this is period 2. So it has only 2 shells. If you look at here, it has 1 shell, 2 shell, 3 shells. It can't be A. Let's look at B here. So B is in group 1, 2, 3, 4, 5. So it has to end with 5 electrons. Here it says 4. Then C. So it has to end with 2 electrons because it's group 2, which is right. Then it has to have 3 shells. 1, 2, 3 shells. Let's see. Period 1, period 2, and period 3. So it has 3 shells. So that's correct. Let's look at D. D should end with 8 electrons because it is in group 8, which is fine. But then D is in period 3. Period 1, period 2, period 3. It has 3 shells. And here it shows only 2 shells. So that's not correct. If you are confused to do it this way, you can look for A in your period table and figure out what is A. So A would be lithium. Then you work out lithium and figure out the electronic configuration. So there's different ways. Sometimes you work out the same question. It all depends like what is easier for you to do. See here, you can have a look like what was A. 16. Correct symbol of lithium ion in lithium chloride. So the ion will be based on your periodic table. So group 1 is +1, group 2 is +2, group 3 is +3, and so on. And lithium is in group 1, so it will be Li+. Now, so we have between B and C. Now, this number does not change. 73 does not change. But then it will be C. Because when we bond an atom with another one, they become ions first. And when they become ions, it's only a change in electrons. Nothing to do with protons and neutrons. 17, which statement comparing the properties, okay. Neutrons and protons are both heavier than electrons. That's right. If I say, for example, my PC weight, let's kind of assign it like this is the weight of a proton. This is how heavy proton will be, the size of my PC. Then the neutron will be exactly the same weight. So protons and neutrons exactly the same weight. But then if I compare my PC with a cover of my marker, like this is the weight of my electron. So this is a big difference of weight. So protons and neutrons are equally the same weight as compared to electron, which is extremely light. So of course it's going to be heavier than electrons. So between A and B. Only electrons and neutrons are charged. No, that's wrong because protons are positively charged, electrons are negatively charged. That's why if I have proton number 5, I have 5 protons, I will also have 5 electrons. So 5 protons will be +5 because protons are positive. If I have 5 electrons, it will be -5 because electrons are negative. +5 -5 is equal to 0. That's why an atom is neutral, because the number of protons is equal to the number of electrons, and because protons are positive, electrons are negative, they cancel out each other. So that's why atoms are neutral. So, but not neutrons. Neutrons don't have any charge. If we have a neutron traveling in a pathway, and there is a positive and a negative field, it will just pass through it straight away because it is not charged. It does not get affected with any charge. So no. You need to remember this. So this should be in your note about the relative mass of each of these subatomic particles and the relative charge and where they situate in an atom. Just make sure you note this properly. Then that one, we have to figure out which row is, electrons is correct. Which row gives the number of electrons in the outer shell, so in the last shell. So remember, in the first shell only 2 fit in, and the rest goes to the second shell. If it is full, it goes to the third shell, as you already know. So if we have 9 protons, but we have 9 electrons as well, but 2 go into the inner shell, and then 7 goes into the outer shell. So read the question properly, because sometimes it might be confusing. There is 9 electrons, as you can see here, but then it says in the outer shell, so 7 in the outer shell, so between A and B, and here we have 10, so we have 2, and then 8 in the outer shell, so that's 8. It's like this, 2 inside and then the 7 outside, 2 inside and then 8 outside. We have to figure out the protons, neutrons and electrons of this isotope of rubidium. So the first thing I'm going to do is I'll look at rubidium in the periodic table. I found out that rubidium, the small number is 37, that's my proton number, so that would be between A and B, 37. Then electron does not change as well, it will remain 37 as well. Directly answer to A. You don't need even to calculate that. You have to take 85 minus 37, and that should give you 48. 20. I think we have similar question. It has a proton number of 18, so that would be argon. The next one is potassium. Of course, but there is one more electron shell, because argon will be in period 1, 2, 3, and potassium will be in period 4. So one extra shell will be for potassium, where one extra electron goes outside. Each atom has twice as many neutrons as protons. So neutrons would be 2 times more than the protons. Okay. Proton 1, neutron 0. Proton 1, neutron 1. Proton 1, neutron 2. Proton 2, neutron 2. So these have identical protons and neutrons. It's this one where we have 2 neutrons but 1 protons. Element X, Y, and Z are in group 7 of the periodic table. X is a gas, Y is less reactive than Z, and Z is a red liquid. So we have to put them in order of the increasing proton number. Okay, so we have to go like smaller proton number to bigger proton number, right? Okay. X, Y, Z are in group 7. So we need to know the trend in group 7. So it is a gas. We're going to learn this into more details when you do periodic table. So when you look at group 7, have your periodic table in front of you. So fluorine and chlorine are gases. Bromine is a liquid. Iodine and acetylene are solid. At least this bit we did it. Alright. So if X is a gas, it has to be the smallest one. So X has to be at the beginning. Then it says Y is less reactive than Z. Usually, in your periodic table for group 7, the more it is at the top, the more reactive it's going to be, which we're going to learn into more details afterward. Okay, so if Y is less reactive than Z, then Z is more reactive, so Z has to be on the top, and hence Y has to be the last one. Okay, don't worry too much if you don't understand this question, because we're going to go into more details about group 7 when you're going to do the topic called periodic table, maybe in a few weeks. Or you can, if you want to, you can also read this as well. Then we have 23. Element X has 7 protons. And then element Y has 8 more protons than 7. This statement about Y is correct. Y has more electron shells than, yeah, that's obviously if you have 8 more protons means you have 8 more electrons, you will have to move to the next shell. So this is very obvious. So which is correct? The number of protons and neutrons is the same. We have to double check. Proton is 11 and neutron will be 23 minus 11, which is 12. So it's not the same. Protons and electrons are same, definitely, because we are talking about atom, not ion. atoms, protons, and electrons will be the same number, which is 11 in this case. So that is correct. The number of outer electrons is 1. So you have to work out the electronic configuration. If we have 11 electrons, it will be 2 in the inner shell. Then you have 8 in the second shell. So that's 10. And then 1 in the outer shell. So that's right. If you're not sure about it, look at sodium in your periodic table. You find out that sodium is in group 1. So it should have 1 electrons in the outer shell. So 23 is correct. 25. Which of these do not form a covalent bond? To form a covalent bond, you need non-metals. So non-metals will not be in group 1, neither in group 2, neither in group 3. They will be above group 3. So like 4, 5, 6, 7. Not 8 as well, because 8, they are unreactive elements. They are monoatomic, means they exist on their own and they do not react with others. So your answer will be between 1, 2, 3, and then 8 in the outer shell. Here's 1. That's the answer. Does not form covalent bond. Here's 4. Here's 2, 4, 6, 7. 2, 4, 6. So all of them are above 3. Which pair of atoms are isotopes? Remember, protons should be same first. Protons, same first. W and Y. Immediately you get the answer. You don't need to even figure out, oh, is it electron same, is it neutron different? So yeah. Which word describe these particles? So we have between isotopes and ions. Okay. Isotopes. Protons, electrons same, neutrons different. Let's see. Protons, neutron same. So this here can't be an isotope because the neutron has to be different. Proton same, but then neutron different. So these two could be isotope, but then there's a problem because the electron is also different. Number of electrons has to be same. So then let's take R and T then. Proton same, neutron different from this one, which is good. Hence, the last thing we have to look at is the number of electrons has to be same as well. 3 electrons. So the answer is R and T should be isotopes. So then there's only one option here, which is option C as the best answer, R and T. Then you can double check with S is an ion. If we look at S here, there's a loss of electrons. Not losing electrons means they give away one, they become positive. It would be S plus, for example. 28. So it says X, we don't know what it is, but I know it's 13, so I can figure out what the element is. If it is 13, the smallest number from the periodic table is aluminum, so that's aluminum. So this statement about aluminum is correct. And atoms of X contain 13 protons and 13 neutrons. Yes, 13 protons, agree. Neutrons will be 27 minus 13, that's 14, so that's wrong. Atom X contains 27 protons, completely wrong. X forms an ion by gaining electrons. If we look at aluminum, aluminum is in group 3. It does not take, it gives away 3. Remember, aluminum forms 3 plus? Yeah, 3 plus because they give away 3. So they don't gain, they lose. So that's wrong. Aluminum is placed in group 3. Yes, it's very obvious. 29. How many protons and neutrons are in the nucleus of the atom, and in which group and period of the periodic table is the element found? Okay, it is an element, so I know the number of electrons will be exactly the same number as proton. 1, 2, 3, 4, 5. So 5 protons and 5 electrons, so 5 will be boron. So I know it's boron. So then I can figure out 5 protons, the answer between A and B. And hence it is, if it is 5, I look at boron, boron is in group 3. There, group number is 3, done. So there is many information you can actually skip because you already figure out your answer. 30. What is different for isotopes of the same element? The nuclear number or the neutron number. That's it. 31. Which element has the atomic structure shown? Again, look at the proton. Proton has not been said. Again, it says element, so I know number of electrons is equal to number of protons. So I figure out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 electrons means 15 protons as well. And that's 15 phosphorus. Yeah, P. How many atoms of hydrogen are there? So we have 5 atoms here of hydrogen and 1 here. So we have 6. Which statement about a neutron is not correct? It can be present in different numbers in atoms of the same element. It can, because this is when we call them isotopes. It has no electrical charge. Agree? Remember, the neutron goes on one line, does not affect by any field of positive or negative. It is always found in the nucleus, which is true. Yeah, always found in there. The protons and the neutrons are always in the nucleus. It weighs much less than a proton. That's wrong. They are equally of the same weight. So that's wrong. So you say which one is not correct. 34. Forms a compound with element. Which statement describes the bonding? Okay. So to be able to know this, we need to know if they're ionic or covalent. If it is ionic, means the metal gives away electrons, they transfer electrons. If they're covalent, means they share electrons. So we need to figure out like which group they are, so it's easier. So the way I would go for this question, I would say, okay, fine, let me figure out the atom. Easier for me. Okay, 9 protons in the periodic table is fluorine. Fluorine is in group 7. So fluorine is here in group 7. So it's a non-metal. And then I figure out 19 proton number, which is potassium. And potassium is a metal. So a metal and a non-metals is ionic bonding. If you can't remember, you have to revise your chemical bonds topic, because we're going to, the next worksheet will be on chemical bonding as well. So we have here potassium, and this is fluorine. Remember, the metals are the one which give electrons, and if potassium is in group 1, it has to give 1 electrons away to the fluorine. So that's why we say Y, which is a potassium, give away 1 electrons to the fluorine. It's a bit like this. Give it down here. 35. Which row is not correct? Okay. 1 calcium, 1 carbon, 3 oxygen. Seems okay. 1 carbon, no, it's not 1 carbon. There's 2 carbon. See? This one here, so that's wrong. We have 5 hydrogen, no, that's wrong, because we have 5 plus 1, 6 hydrogen. So that's why it's not correct. 36. The number of protons is B. Okay, it says A. The exact position of X in the periodic table can be found from A. No, that's wrong. It's from B, the proton number. This is where we figure out where they are in the periodic table. The relative atomic mass is the big number on the top, which is B. No, it is A. The big number on the top is A, which is of course the opposite from your periodic table. The total number of electrons in one atom of X is B. Yeah, because the number of protons is equal to the number of electrons, which is B, as it is an element that we are talking about, not an ion. And that's it.